Test. Test. 1, 2, 3. Test. 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 1, 2, 3. Alright, hello everybody. Welcome to the Jubal live coding stream. This is my first time streaming, so, if anything is up, anything's wrong, please just let me know and I'll try and fix it. If the terminal font is too small to read, I try to make it big so you can see it. And the volume is off. My mic's not very good, but we'll just do the best. Just do the best we can. And I think there's a bit of a delay between when I'm talking and when the audio goes out, so just keep that in mind. Alright, so this project is Jubal. So Jubal is basically a computer audio application. The idea is basically it's going to be kind of like, I don't know if you're familiar with the old trackers from back in the 90s, early 2000s, impulse tracker, fast tracker, etc. But it's going to be something in that vein. The only difference is instead of working exclusively with samples, it's going to have a series of sound generators, synthesizers, effects, etc. And so instead of just being samples, you could have an FM synthesizer, a subtractive synthesizer, all those things. Yeah. So, as you can see, I kind of already have some work in progress. I'm sorry, but you're probably not going to get to hear it yet. First off, I haven't quite figured out how to get the audio from the applications streaming over the live stream. And secondly, it's just not quite ready to do that yet. Okay, so I guess that's enough of an introduction. If you have any questions, just ask them in the chat, and then I'll be sure to try and address them. Okay, so without any further ado, let's get started. Okay, so the first thing which I'm going to do is I have to make some edits to the engine. What's it called? Engine. Yeah, there we are. So you can see here's the engine. Oh wait, I don't think I'm on the right get revision. Sorry about that. Okay, so basically, with this audio program here, a very important concept is the concept of real time. So on the real time thread, Oh, yes, Flex Bum. Yeah, I'm sorry, I'm saying that, sorry. Hello to you too. And you too, Alexander. Okay, so like I was saying, so there's the concept of the real-time thread. Alright, so when the audio process is running, the driver has to get a certain number of samples every buffer period. So the exact number will depend on your settings, but it could be 128 samples or something like that. So that means that your engine thread, the one that's feeding the audio data to the driver, has to be real-time safe. So that means you can't use certain programming constructs. You can't do memory allocations. You can't use standard mutexes. Because the risk is you could cause a lock, and aside from the problems of deadlock, there's also context switching, and then any kind of thing like that is just too slow to use on the real-time thread because it'll cause a glitch in the output audio. So you have to use some special constructs. The first one is a lock-free FIFO queue. Alright, so I'll just show that one off first. So here's the lock-free message queue. You're wondering how it can be lock-free. Basically, we do that with some atomic operations. If we were using C++11, then maybe we could try out some of the let's see. Okay, FlexBomb. All right. I'll answer your question now. But I'm afraid there'll be a bit of delay between when I start talking and when the stream goes. So basically, Jubal is a computer music application, and what it will do is it will basically, if you remember sort of the old trackers, Impulse Tracker, Fast Tracker 2, etc. It's similar to that. However, instead of just sequencing samples, you will be able to sequence not arbitrary, but a larger class of sound generators and sound processors. So it will be like, you can have a FM synthesizer, a subtractive synthesizer, reverb, etc. So it's kind of like a digital audio workstation, but it's a very more minimalistic in intent than something like Ableton Live or Cubase or something like that. Yeah, so I hope that answers your question. I can get into some more detail later. So the lock-free message queue is a very important construct, and so this is just the basic API here. This one right here is only safe. Well, I say safe. It's kind of in quotes because it's it's not 100% safe. When you're dealing with these kind of low-level type atomic operations, memory fences and etc. It's really easy to mess up. So I think it's safe for now, but jury's still out. I haven't had any problems with it yet, but it could always run into problems in the future. So you may be wondering how you would implement that. So you can see all these calls here to sync_synchronize. So that is a GCC built-in function. So basically, that would output, your mfence, etc. Well, it would be mfence on x86, but it would be different on a different architecture. So it'll output those assembly primitives where I'm calling this function here, and then those basically if you have your function running on different cores, you want to make sure that the cache is not caching the old value of the queue messages, and just like that. And okay, so you may also be wondering, okay, so using underscore sync synchronize like that, doesn't that limit you to just GCC? Well, it turns out Clang also supports this. So, if GCC and Clang works on both of those, I don't really have thousands of dollars to be buying whatever Portland Group's C compiler, and it says right now it's Linux only, because Visual Studio, if this wouldn't work in Visual Studio, but Visual Studio doesn't even support C99. So, I already couldn't use Visual Studio. Yeah. Alright, so that's that. So, next thing, okay, so what we're going to be doing now is editing the engine struct to kind of parcel out the different functions the different members into real-time and non-real-time classes. Just not classes in a C++ sense, but just in different types. Actually, I had a git commit, but I think I lost it. Let me just. Sorry about this, folks. Actually, I made a mistake earlier. I was on a different Git branch, and then I accidentally kind of overwrote the commit, so I just had to look up the command there, and I'm just going to pull. Oh, shoot. Whoops. Okay, there we are. Never mind. Okay, I was on the wrong branch. Now let's see if that's better. Yes, okay. Sorry about that. I was on the wrong Git branch. I was like, oh no. Alright, so you can see here I've already started to parcel it out into a real-time struct and a non-real-time struct. Alright, so just go over each of these members here, I guess. So node order. Actually, I'll switch to drawing so you can kind of see this better. So basically, you can think of the system like a directed acyclical graph. Alright, so we have each of these on here. It's a little big. Alright. Each of these objects here, these could be the different kind of nodes in your system. The nodes would be whatever, like a synthesizer or a effects processor like reverb or something like that. So you have all these different nodes in your system, and each node has inputs and outputs. All right, so let's say I'm going to draw the arrows pointing from the node to its input. All right. So let's say that feeds into there. This one to there. This one feeds to there. Maybe this is some kind of, I don't know, something that takes in 2 inputs and then it does something to it. All right, and this is just another one. And here is output. Alright, so now the challenge, basically what the engine has to do is, given this set of nodes and the connections between them, it has to create an ordering of execution. So it will process each node only after all of its inputs have been processed. Now this is kind of important, so I'm just going to emphasize that again. Each node is an audio unit, essentially. So this would be something like a VST or a LADSPA plugin, if you're familiar with those terms, or an audio unit from the Mac world. And each one can have any number of inputs and any number of outputs. And the Jubal engine has to come up with some execution order so that each audio node is only executed after all of its inputs are ready. Okay, so that's the basic idea. So once you have that conceptual concept, whoops, you didn't just see that. I'll show you how we kind of put that into code here. So basically, I started off with one way of doing it, but now I'm changing to another way. So I'll just tell you about the first way first. So the first way, whoops. Okay, so the first way, basically, what I did was I stored the nodes in reverse order. So and I used a bit set for connections. Alright, so basically, I'll just draw this out. I think that might make more sense. Alright, so we've got node from and node 2. Alright, and then we have our bit set, which will just be set to 1 if this node is an input to this node. And then we have like another special one for if it's connected to the output. Alright, so this might be like whatever. Alright, so maybe that's connected to that one, not to that one, to that one, not to that one, to that one, and not to that one. Alright, so that's the basic idea here. Alright, so you have this bit set data struct. It's essentially, if you know your graph terms, it's just an adjacency matrix, but it's just expressed with a bit set instead of because that allows us to have less memory used. And then, in order to traverse it, we start at the output, and what we do is we go down these links. I'll switch to red here actually. So you can see the traversal order. We start at the output node, and for each one connected, we go here, and then we go down to that one, and do that one's input, and then we do this one's input, and then we go back up when we're done. So it's essentially a post order post order traversal. Alright, so that was the first way I was doing it, and then I'll just show you that in code here. Oops. Alright, so this is just how we're iterating through the bit set. For each set bit, I made the bit set API kind of similar to Java's bit set API. So if you're familiar with that, you will understand this as well. So I go through each set bit, then get the pointers to the input and output, copy the input to, mix that output to the main output of the node that's going to be traversed, and call traverse helper. Alright, so traverse helper is basically the post order traversal function. And you see it's a little bit messier than it should be because we have got to repeat the same thing for the left input and right input and left output and right output, so we're going to change that as well. Yeah. Okay, so you can see very similar to the other one. Alright, so for the node, what we have to do is first we find the set inputs, and then we recurse if we have not already processed that input, and if we haven't, then we traverse helper it. So you got your standard recursion there, and then after traverse helper returns, that node will have been completely resolved, all of its inputs processed and mixed, and then we can proceed to put it into the input buffer and evaluate the node. Alright. So like I said, that was the old way of doing it. I'm going to rewrite this because the problem is with this method I don't have a good way of from the UI thread, I don't have a good way of detecting if the user has created a cycle in the audio graph, which would be very bad because you have an infinite recursion here and Stack Overflow. So I'm going to change this, and instead I'm going to do a topological sort, and then when you have it in sorted order, then you can just iterate right through that. Okay. So I guess that's all you need to know about that for now. I was talking earlier about the lock-free queue. So here's how the lock-free queue comes into play. This is the callback function. So this will basically be run on the audio thread, and that's provided by you pass in a callback to whatever audio backend you're using. Like I said, I'm on Linux, so this would be like ULSA or Jack. On Mac, you would use Core Audio, and on Windows, you have there's so many. MME, DirectX, Audio, WhatsApp, and then whatever the other one from Steinberg. ACO. And this function will just be called periodically whenever the driver says, I need more frames. I need more audio frames processed. So, yeah. And then, you can see here, the first thing we do is we check the queue for any messages that we need to process. And as you can see, this is a pretty, I don't know, I don't like this. I don't know, I want to change this and make this part better too. See, basically you just have the different types of nodes, and there's, different things you do for each one. I guess some of the ones worth pointing out is we have a note on message. So that would be like a MIDI note on, so whether it's coming from the sequencer or from the a keyboard or something. It would send a note on for as long as you held it down or as long as the note was playing, and then when it's done, it would send a note off. As you see, to do change this, yes. Like I said, I want to change that. Note off is pretty self-explanatory. Then we have a control change, so that would be, if you have like a real synthesizer, you would do that by tweaking knobs, or if you have one of those ones from the 80s, then you have to go through all the menus on the stupid front panel and just go through all that. But here, it's just a CC message. Change definition, so that is basically if you have a you're just changing the type of the node, which would be the node def. So if you wanted to change one of the nodes in your graph and just make it into like a from it was a synthesizer, but you want to make it into a reverb now, or something like that, then that's the message you would send. Then we have your graph messages, which is basically connecting nodes, disconnecting nodes, and connecting the output to the system out and disconnecting from the system out. So like I said before, I'm using a bit set, and you can see this is kind of ugly as well. I need to have a little better API maybe for the bit set. I don't know. And then finally, the system messages. So these would a lot of times these cause you to restart the engine. In this example, in Jubal, I think I can get away with not restarting the engine. I can just kind of change it on the fly like that. So that would be changing the sample rate of the system, the buffer size. Like I said before, the audio driver, he's asking for that buffer size of input. So if the user changed that, like they set it to 128, and then their system couldn't handle going that fast, they changed it to 1024 or something like that. That's that. Changing the number of nodes. Yeah, see, this is another part that is kind of troubling about this, is that you can't call malloc from this audio callback thread. It's just you don't know what malloc is doing. It can cause context changes and just totally glitch out your audio. So you tended to do a lot of stuff in fixed sizes. So what I have here is I just have a default number of nodes, which is a pretty high number. I think it's like 256 or 1024. Or, you can change the default at compile time. It's not a big deal, but if you want to change the number of nodes while it's running, you have to reallocate those buffers in a different thread and then pass them to this function in this message struct, and this function will swap out the pointers to the new buffers, and then it'll send a message to the non-real-time thread to free those other buffers. So you can see it gets a little complicated. Yeah. Right. Alright, so in order to make life a little bit more sane, I have wrapper functions that change buffer size, change sample rate, etc. That just create these message structs and handle all that for you. There's nothing too much to see here. I'm going to be changing this RT message type soon enough, so don't memorize it. Yeah. Okay. I think that's enough background, I hope. So I think I will go ahead and get to work. Alright, so build. No. Okay, so like I was saying before, the first change which I'm doing is before I had everything in this engine struct, and so right now I'm parceling it out into engine RT, which is engine real time, and engine non-RT, which is the non-real-time thread. And the shared communications should be able to be written to from both threads. And yeah, so this is just a way of kind of making sure that we don't accidentally, write to the real-time thread from the non-real-time thread, and vice versa. So hopefully, when I see, engine.rt, that'll be a little red flag if it's in the non-RT section. Alright, so yeah. Okay, so like I said before, I also want to change the way the engine processes the nodes. So instead of doing the post-order traversal, we'll instead do a topological sort, and then the topological sort algorithm will output, whether or not there's a cycle, and we will change. The key part is we do the topological sort in the non-real-time thread. So basically, in like the UI thread, and then we can tell if there's going to be a cycle before we give it to the engine. At least that's how it should work in theory. So that way we can alert the user that there's been a cycle, and the engine doesn't even have to know that they tried to do that. Okay. So we just need to update all these engine functions. At least everything that calls engine. Alright. Alright, so alright, good. It looks like we're mostly only calling those engine functions from engine.c, so everything should be in pretty much one place. Alright, so I'm just going to write a note here to myself that all these functions here are non-real-time. Oops. And again, if anyone has any questions, feel free to ask, and I will try and answer them. Hello to the cat who barks loud. Alright, so now we need to update these functions. To use the new engine API. So, alright, engine paused. Okay, so as you can see here, I'm using the sync bool compare and swap. So that is an atomic operation, at least on x86. I think on some of the other architectures, I'm only targeting x86 or x86 and x86-64, but in this aspect, they're the same. So, yeah, that's another one of those __ sync built-in functions, which I was talking about earlier. Alright, so that doesn't need to be changed. Alright. Alright, that's fine. I think this is RT. Alright, that's okay. Oh yeah, not supported yet, because I was changing the way I was doing the routes, so yeah. It'll be eventually supported, but on the other hand, maybe there really is kind of a maximum number of nodes that you really need. I mean, are you going to be having 1,000 instruments? maybe you are 16,384. Maybe. But I think that there's a limit on what the mind can process and keep track of. Okay, that's good. Fine. Okay. Depths. That might need to be changed. Actually, most of these are fine. I'm just going to check the make error log. Alright, 3UV9. Okay. And 292, okay. Okay, mailbox. Okay, so I'll talk about the mailbox system. Alright, so before I was talking about all the different kind of queues and how we have the real-time messaging queue. Alright, so all that the Jubal engine does is it takes those messages and sorts them based off of time and node recipient, and then that node, each node in the system has a mailbox which is then filled with these messages. So it's up to each individual node to process the messages in whichever way it thinks is best. Okay, here we are. Oops. Alright, most of them. Engine RT is no member. Okay. I changed some of the names, that's right. Whoops. Okay, let me see what did I change the names to. Okay, that's a non-RT route. Okay. Same thing here, I bet, yep. Let's go up. Okay, here we are. Yep. Yep. Okay. Okay, so you see how this function is called make underscore engine, returns a pointer to an engine. So basically that's just kind of I'm doing it in C, so that would be kind of the equivalent of a C++ constructor. But we don't have classes in C, so we have make underscore functions to make it. Actually, let me just check that definition real quick. Make sure that is if it's an RT or non-RT. Yes, it's an RT. Okay, good. Oops. Alright, so you can already see how kind of tedious it is dealing with left and right audio streams differently. Alright, so just a little bit of background on these audio streams. So basically what they are is just a buffer of floating point numbers. The number is just basically the amplitude of the audio signal, and the time between each sample is determined by the sampling rate. So each floating point number is one sample. So if you have a sampling rate of 48 kilohertz, then you have 48,000 samples in a second, and you have one of these audio streams for each channel. So right now Jubal is only supporting stereo. Maybe in the future we can have an arbitrary number of channels, but for right now, stereo. And so we have got a couple of different ways that you can represent a stereo audio stream. So one way is you can have an interleaved buffer. So basically what that is instead of having two separate buffers, you have one buffer, and it's like you have actually, you know what, I'll just draw this out here. It looks whoops, that wasn't very good. I'll switch back to black. Alright, so basically it's like left, right, left, right, left, right, left, right, etc. And that goes to a length of 2 buffer lengths, because you have 2 channels. Alright, the other way is to have 2 separate streams, like L. Hang on, let's see, 1, 2, 3, 4. 4. 2, 3. And this would be a really, really advanced system if we could have a buffer length of only 4. Wow. But, it's not realistic, but it's just an example. Alright, so in this one we have the streams are kept separated. And each stream is one, just to make it a little more clear, it's 2 times, whoops, that's not very good, okay, that's 2 times buffer length, and this one is just buffer length. So you see, this is the interleaved way of doing the audio stream, and this is the separate channel way. And you can imagine if you have like n channels, say, or some kind of surround sound thing, 5.1, your 6 channels, or 7.1, 8 channels, etc. It would just be channel 1, 2, 3, 4, etc. Just like you have LR, 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 LR. It would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, or it'd be 1, 1, 1, 1, 2, 2, 2, 2, 3, 3, 3, 3, 4, 4, 4, 4. Alright, so different audio APIs use use these different ways. I think VST on Windows is by default interleaved. However, since I am using Linux, the best Linux audio API for this kind of pro audio low latency work is Jack, and Jack uses separate buffers. So, okay. So, oh yeah. So that is why we have separate left input and right input, and left input and right output. But like I said before, it gets really kind of unwieldy dealing with these different pointers. So I also really need to build out a separate kind of struct that can embody this idea, and then you just have just that struct, and it'll just be the audio stream, and you have whatever left, right, etc. all in there. Okay, back to work. Oh, okay, so another thing maybe wondering is, alright, so why is sane a member of the engine? Why don't you just, it's only going to have one bit for each audio node in the system, so why don't you just create it on the fly? Alright, the reason again is because, even though it is only 256 bits, we can't call malloc from the audio thread, from the real-time audio thread. So, we have to kind of keep stuff up front, allocate it up front. Some other projects, I think like Super Collider, what they do is they write their own garbage collector, and I'm just allocating stuff I need up front, and that's enough for me. Maybe in the future write your own garbage collector, but not for now. Yeah. Alright, so if you're wondering about the format of mailbox and mailbox size, so mailbox is just, you can see from the malloc call here, it's just room for the message. It's just, a big array of messages. And each node, when you call its evaluation function, you'll just pass in the pointer to the right one, and same thing with mailbox size, so that's just a big array of integers. Outcon here. Alright, so this is the bit set that tells me whether nodes are connected to the output. So as kind of a way of introducing a little bit more efficiency, what I do in Jubal is there's no need to render an audio node if the person isn't going to hear it. So if it's not connected to the output, and the way it's connected to the output is determined kind of recursively. I can show you a little more about that later. But anyway, the point is, if it's not connected to the output, then there's no reason to render it. So we can save kind of a little bit of processing time. Although, it probably wouldn't be too inefficient to just render it, because, most of these functions tend to be fairly fast, but there's no reason to just leave that on the table. Leave that optimization out, because it's just so easy to edit in. Alright. Oh, I know this one says has cycle, but this actually doesn't work. Oh wait. Got this, property of directed acyclic graphs. Alright, a directed graph is acyclic if and only if it has no back edges and a DFS. So this is trying to do that. It's got an off by one error. I'm still investigating, debugging that, but we're going to switch to the topological sort anyway, so I didn't want to spend too much time fixing this. Okay. And as you can see again, it gets kind of unwieldy having separate left and right inputs. Yeah. Alright, that's most of it. Oh. Okay, so I'll show you some of the audio node, how that works in just a little bit. And just fix my call to the evaluation function. So as you can see here, this is just a way of doing like kind of 2D array indexing into a 1D array buffer index. So as you saw before, we only have one pointer for mailbox node or whatever, and I don't know, things just get a little wonky with the way that arrays decay to pointers. So that's why I'm just kind of doing it like this. Not the best, but not the best way to do it. Yeah. And I'm already seeing in here a couple of times where I read from the RT struct from the non-RT thread. So we've encountered a little bug here that might have been difficult to find otherwise. So I'm glad I did this. Yeah, and not too much to say here. I can show you the way I wrote the bit set and the nodes in a little bit. That might be more interesting. Yeah. Alright. Sorry, not much commentary here. There's just not much to say. But a lot of programming. It's not always interesting. So, okay. Well, I guess I can talk about this. Okay, so you see how there's a member here called nodes. So, like I said before, we allocate all the memory up front. So this nodes buffer has just got, it's just a buffer that is full of allocated audio node instances. And like I said, I will show you that in a bit. Another thing you might be wondering, is why running in C. Well, what it is there is a small set of languages that you actually can use for these audio purposes. The main reason being that The main reason being, of course, efficiency, but also determinism is really the bigger issue than speed. So what happens is, in a lot of these garbage collected languages, like Java, etc., the Java garbage collector, at least the default one, in wherever the Oracle JVM, I think there's some different JVMs, which have different garbage collecting strategies, but when the garbage collector invokes, it can introduce like these latency spikes, which can, like I said before, if that happens on the audio real-time thread, that'll cause glitches. It's just terrible. So you gotta watch out for that. It can be done. I've seen it done before, but you end up having to be so careful about all your memory allocations and memory usage that you end up giving away a lot of the benefit of the garbage collector. So, because you have to keep track of like what all the memory and what the garbage collector is already doing. So, might as well just handle the memory yourself. It's also not that much work to manage this memory, mostly because, like I said before, we pretty much just allocate everything up front and then just use it. There again, you see how it gets annoying to deal with separate left and right inputs and outputs. More. I apologize for this, folks. I'm sure you wanted to see more of a stream than just seeing me type in RT a million times. But I guess that kind of shows you how much of the work is done in the real-time thread and with real-time data as opposed to the non-real-time thread. Alright, what's the problem now? Route. Okay, queue size. Defs, okay. That's it. Was it RT defs? That's it. Routes, okay. 50. That cycle isn't working anyway, so I'll just comment that out, and we'll come back to it later. Okay, almost there. No memory called defs. No memory called, okay. Like that. Size. Oh. Okay, route. Oh, right. That's in the non-RT. So anyway, part of doing this with RT and non-RT, it's kind of like making a pseudo type system just to help catch errors, like using the RT data in non-RT function and vice versa. Because C's type system can't quite handle that, so we need to do this ourselves. Okay. 54. Alright, getting close. Conflicting types for has cycle. Let's see, has cycle. Oh, that's because I was changing that to make it actually work. To find the back edges. So we needed to pass more information into it. Alright, so engine.h, whoops. There we go. It has cycle helper. Alright, yep, that's definitely wrong. As you can see here, we had to add in the extra visiting and done instead of just seen. So, you know, if you remember your algorithms classes, so basically visiting would just be the gray node, white node would be not in either bit set, and black would be in done. Same thing with has cycle helper. As you can see again, added the additional visiting and changed seen to done. Alright. Whoops. That's something else. I must have... Engine. Oh, I know what it is. I forgot to add the semicolon on the end of the line. Alright, good. And just a couple more errors left to fix. Like I said before, it's in a bit of a state of flux here. So I'm actually just going to return false here because this function will be completely different once I switch it to use the topological sort based backend instead of the post order traversal one. Alright, so alright. 1, 2, 3, 4. Missed a parenthesis here. Asterisk within comment. Oh, okay, I forgot to close that comment. I don't know, not a big deal, I guess. Is that an error? No, it's just a warning. Actually, that will cause an error because the first, see here, this first line / asterisk here, that'll be closed here. So you see the comment only goes from there to there, not from there to the end like I was intending. So anyone not familiar with C, you know, that's a definite problem. The comments don't nest. So, you know, if you're coming from OCaml or something, you know, you are used to nested comments. This one does not have that. So instead, I'll use another commenting technique This is just commenting it out with the preprocessor. So if 0, of course that will be false. Include that, and if. There you go. Alright, great. Now we can actually fit all the errors on our screen. Just a couple things. Route and 2 warnings. Okay. Yes, non-RT route. And now we have a binary. So, unfortunately, I can't actually run this binary because it connects the jack, and when it connects the jack, that will shut my microphone off, I believe, because my microphone is going through pulse audio, and then jack needs exclusive control of the sound card. So, just kind of the fun things of, trying to stream developing an audio app when you're using the audio to talk. So, yeah, a bit of an issue with that. Maybe in the future I can get that to work, but, otherwise, you're not really missing out too much. The only modules I have right now is just a sine wave and then random white noise. So, if you don't know what a sine wave or white noise is like, just Google it or, YouTube it or something like that. I'm sure you can find an example and just kind of imagine what it would sound like. Okay, so now, like I promised, now we got some of that, fiddly, boring part out of the way. I'll show you some more interesting parts. Alright, so first thing I'll show you is the nodes, okay? So, okay, so this one right here, nodes.h, so this is just exporting all the different symbols for the different audio def nodes. Nothing really that interesting, just the disabled one, that's just the dummy one that does nothing, and the sine one, and then I don't have the white noise one here, but, trust me, I can write it. Okay. So, so we go to the engine header, and then we can see the definition. Alright, so basically, the way which I'm doing the audio def and the audio node is just kind of a way where you can kind of shoehorn in, well, maybe it's not fair to say it's shoehorning, but just a way to get C to have sort of an interface implementation split. So this would be basically like the C way of doing a C++ virtual class or a Java interface. Alright, so basically the way it works, so we've got these audio defs. The audio def is the actual interface, the interface definition for the node, so there will only be one of them, one for each class of node in the program. So, just some things about that. It's got a name, some controls, and this part needs to be kind of fleshed out a little more, and given some more information. Like the way which LADSPA does it is, it lets you specify, like for each control, like what is the max and the min value acceptable, should be rendered with a logarithmic scale, linear scale, exponential scale, etc. So basically, this definition here is just going to be giving hints to the GUI for how to render and draw the control. Yes, okay, so after that we have a series of function pointers which will be implemented differently for each node definition. So we have the make, so that's basically your constructor. Init, difference between make and init is that make will actually call memory allocation, It'll call malloc. Well, it could potentially call malloc. It doesn't have to, but make makes make unsuitable for use in the real-time thread because it could allocate memory. Init will simply take the already allocated memory for the node and actually, I don't think I'm using init for anything right now, but there'll be a difference. Alright, so eval is the real key to the whole system. So as you can see, eval takes input, this void pointer, so that's to the instance data. So the instance is kind of like the pimple idiom, if you're familiar with C++. So this instance data will be casted by this eval function to the right type, and it will operate on it like that. So this is kind of a functional interface, almost, because you are passing everything you need to the function. As you can see, we have our mess again with left, right, inputs and outputs. And see, it's taking up like 4 parameters there, and it obviously gets unwieldy. Especially if, and I'm not planning on doing this, but if I go on to more than stereo, then you can't. It would just get crazy. You're having like 8 inputs to a function. So whatever, that will need to be changed. The sample rate, because some evaluations functions would need to know that. For example, if you have a filter, then you have to know the sample rate of the system to make sure that you're avoiding aliasing. Or if you want to have your synthesizer be doing oversampling, it helps to know the sampling rate of the system. And then finally, we pass in the number of messages, which is from that global struct in the engine, or sorry, the big buffer in the engine for the number of messages, and then the pointer to the actual message data. And then a free function. So read and write. These are basically just intended to be serialization functions. So that was what you would use if you're loading, writing plugins to disk, like presets, that kind of thing, or you're saving the song. All right. So then we get to the audio node struct, which is really simple. All we have is just a def. Right here, you can see it's a uint8 because, this is on a 64-bit system. So, the pointers are 64-bit. This is 8-bit. There is still padding and stuff. It could be a pointer, but when you're writing it out to disk, it'll have to change into a number anyway, so might as well just keep it at a number now. And then this void pointer to the data, so that is basically what you would be passing into the instance parameter of the evaluation function. Alright, so that's all well and good. So here's just an example of the sine one. So you can see the sine structure here has just got the frequency, the time, and whether it's on or off. When we make it, that data is just only going to be a struct sine. Freeing is just free. In case you didn't know this, that's how you compute the note frequency from a given MIDI note. It's just 2 to the... you can read the formula there. If you want to know more about it, you can look that up on your own time. Alright, so here's the real core of the matter, the evaluation function. So here you see, first we cast the data back into a struct sine. Then we go through each sample in the output, and we compute. Okay, so one of the goals of Jubal is to have sample accurate timing for messages. So on each sample, and it's to check if the next message should be executed on that sample. So you see here, it's only checking for note on. There's no controls, and note off. Okay. And compute the sine wave. That's just your standard sine wave formula. A sine 2 pi f t. So it just fills it in with the appropriate whatever. Copy it to the left and right output. Alright, and then disabled, set it to 0. Here's the noise function. It's not great. So I'm actually also wanting to write a more efficient noise function, because you don't need to pull out rands. You can just use, it doesn't have to be that random. Rand isn't even that random. Doesn't even have to be as random as rand. Yeah, because all that matters is just if it sounds random to your ear, and the ear is less discerning than an actual, cryptographic test. Yes, and you can see these are how you would define it. So this was, name, number of controls, etc. All the function pointers all wired up correctly, and so on. If you want to see something a little bit more exciting, I do have something here. I can show you demo of the wait, that might not work. Never mind. Hang on. Whoops. Sorry, I lost my train of thought there for a second. Okay, yeah, so I do have a little thing I can show you, which is the song editor. This won't be the final interface, but it is just a simple one. Simple incurses interface. Reaper's on the right side. Alright, so here you can kind of get an idea of what the actual interface may look like. This is just, it doesn't actually do anything yet. It's just so I don't have to write demo songs in hex editor. Obviously eventually I want to replace it with an actual GUI. So you can see here is the song info screen. You can give it a name, right? Author, and so on. Highlight the different fields. You can switch. So here's the song screen. So basically, like I said before, this is intended to be kind of like a throwback to the older tracker type interfaces. So a song is simply a sequence of patterns. So here you would write in the pattern, the order of patterns to execute. Then on the pattern screen, so you can see a pattern consists of a series of tracks, and each track has different notes. So you would enter in the notes on the keyboard, kind of like this, right? So I guess you can't really see that, but you can just kind of hit the keys here, and it's like a piano almost. kind of move around or whatever. You can add more, change the octave. Change the instrument number. So this number here in this column, you can edit it or whatever. But you can also change which one is by default with the instrument editor. You can switch which pattern you're on. Whoops. Like I said, this is not production ready. This editor here. It's just for my purposes, and for the final one, of course, it will have more graphics and that kind of stuff. This is just a sample. Oh, and finally the routing matrix. So here you can say, oh, I want this to map to that, etc. X's are connected. Dots are not. And the node editor, which doesn't have anything in it yet. Help. Sorry about that. Oh, there's also some other commands I was working on kind of like a Vim-like interface here, so you can do colon commands. Was it title, test, alright, whatever, author, name, etc. Saving works. Test that Jubal. Quit. Alright. Load. And you can see how I filled in the author name and the pattern we wrote. Alright. But yeah. Okay. Alright. Back to some of the code now, I guess. I guess I'll show you the bit set. Alright, so this is based on the bit set mentioned in the CFAQ. So if you're not familiar with a bit set, basically it's like, alright, so let me make a new drawing here. Alright, so if you have a 32-bit integer, right? That's like a uint32 underscore t. Actually, you know what? That's too much. I don't want to draw out 32 bits. Alright, so if you have an 8-bit integer, then you know you have 8 bits, right? Whoops. 1, 2, 3, 4, 5, 6, 7, 8. So basically, a bit set is just a way of representing Boolean values, true or false, using this number. Alright, so regularly, if you use the Boolean, due to alignment and that kind of stuff, it's going to be, maybe a whole byte just to represent, 1 or 0. But you can actually use a bit to represent the same data. So that's just kind of more efficient memory-wise to do that. Whoops. Sorry about that. Alright, so you can see the code is kind of, I use macros just because, there's no need to have a function just for doing a bitwise and you find the slot because of bit size, because we want to handle bit sets which are larger than an integer, and interesting thing about next set bit, which I'll also show off. I have a fallback implementation, which is implemented in C. That's from Hacker's Delight. Great book. If you haven't read it, definitely you want to check that out. But there's also a GCC built-in function we can use that will execute the. There's actually on x86, x86 64. There is a single instruction which can get you that leading 0 bit. So a little more fish and then using this whole function to do it. Yeah. And I don't know if there's anything else I have to show off now. I'm sorry, I realized I didn't do much interesting coding now, but maybe in the future, just kind of getting into just some of the background, explaining some of the existing code works, but maybe more new development in the future. So that's pretty much, I guess, all I have for you today. Feel free to ask me any questions you like. You can do that in the thread on Reddit, or in the YouTube comments, or anything like that. So I guess I'll see you guys later, and maybe hopefully we'll get more into some more interesting coding next time. Alright. Bye.